Hello everyone, welcome to Vigyan Bharat. In this video, we're going to discuss the solution of the problem of the day for 20th of July 2022. The problem is based on counting techniques. So first, let's quickly recall the total problems that were given. This was the first problem, which says that if our positions are to be filled from n objects, then the total number of possible ways in this can be done. Let's move forward. Then we defined the binomial theorem, which is a very important result in counting techniques. The theorem says that what we are doing basically here, if you see the left side of this expression x plus y whole to the power n, the base term x plus y is indeed a binomial expression because it is the sum of two terms and we are raising its power. Now on the right hand side we are expressing it in terms of summation, where the terms are nothing but raised to the power of the individual terms of the binomial expression, which involve a binomial coefficient which is denoted by nck. Let me write it over here, just mark it. If you see this one, this, then this is called, we pronounce it as n choose k. N choose k, that is, we have a total of n objects. Now we are interested the number of possible ways in which we can choose k out of them. Let's move ahead now. Although I answered, but this was the second question which you are supposed to answer, and I will explain it again. After this, the third and fourth result we have to prove. So let's go back again to the problem. In the first problem, it is very simple. Let's try to think over this. Let me have some space for me. Yeah, no, it's fine. I'm having a total of r positions. I'm having a total of r places, and which I can fill from a total of n objects. Let me choose some particular values of r and n so that you can quickly understand. Let us suppose that r to be 3 and n to be 6. What it means that I have a total of 3 positions. So let me just quickly make 3 positions. This looks fine. So I don't know why my plan is going slightly towards the right today. Now, much better. Yeah. So these 3 boxes, suppose we have these 3 positions I have, and now I'm interested to fill these 3 positions out of a total of 6 objects. These are the total objects which I have. So now the first question is, let me mark these boxes. This is the first box, this is the second box, and this is the third box. Okay. So now the question is, in the first box, in how many number of ways I can fill this box? Since I have a total of 6 objects, so anyone from the total 6 can come over here. So I have a total of 6 possibilities for filling this box. Fine. Now, when I have make a choice out of the total 6, then the second position can be filled by the remaining 5, because one I have already, out of the 6 I have filled, someone had occupied this place. I don't know who is that, but remaining 5 choices I have for the second box. Similarly, for the third box I have a total of 4 choices. So by I would say the total number of possible ways would be 6 times 5 times 4, which is indeed, you can easily calculate this, it would be 120. So there are 120 possible ways of filling these 3 boxes out of a total of 6 objects. Fine. Now try to look over here. How can I rewrite it again in terms of factorial? This was my answer. What I can do here, if I multiply it, like I want to expand it, I am multiplying it by 3 to 1, and I can divide it also. This is, I can multiply and divide by some non-zero quantity. It's totally correct. Let me just make some more space and just rub this one. We have already understood this, we don't require. Yeah. So try to observe it carefully. Now the numerator is nothing but 6 factorial and the denominator is nothing but 3 factorial. This was our n and this was our 3 factorial can be expressed as 6 minus 3 factorial. Pause the video and try to think it. It's very simple now. So this is n factorial upon n minus r factorial. This is a rule which I have just find in order to answer this one. There is a notation which in mathematics we denoted by NPR, that is the number of possible ways in which R objects can be arranged from a total of n given choices. So the number of possible ways is this. This is the answer, or we can write it as the first position can be filled by n ways, the second position can be filled by n minus 1 ways, the rth position will be filled by n minus r plus 1. So this will be the number of possible ways, and if you now try to generalize this, that is for over here, that what you can do, you can multiply over by n minus r minus 1 and so on till 3 to 1, and divided also by the same quantity n minus r minus 1 till 3 to 1. So this whole quantity will be, let me just make some space for me. So this quantity will be, on the numerator I have again n factorial, and in the denominator I have n minus r factorial. So this, but I wrote it over just before by choosing some particular value. So in general I have now expressed this. So this is the number of possible ways which we denote by NPR. I hope the first question is clear to you. You can verify it again for some different possible choices of n and r. Let's move ahead now in the problem. This is the very famous result binomial theorem, and on this we have to answer certain questions which were asked yesterday. So on the left hand side you see this term is a binomial expression. Binomial expression. Binomial means 2 and the expression means, because we are now adding these two terms, this one term, this is another, so this whole is a binomial expression. And in binomial theorem what we are doing, we are raising the power of this expression, and how we are trying to write it in terms of the binomial coefficient. Now in general I am writing the binomial coefficient is defined by the following: n factorial upon n minus r factorial. This was our NPR, and now I am dividing by r factorial. So this is the definition of NCK. Now the question is what this symbol NCK represents. So the coefficient NCK represents the number of ways in which we can choose the k factors providing the y's. That is, we have this expression x to the power k y to the power n minus k. This formula is symmetric. You can easily verify in both k. You can replace simply it by n minus k and here by k to work. It is symmetric. So this nck over here, the coefficient of this term represent, this nck represent basically what? The number of ways in which we can choose the k factors which contain my x. How many ways in which you can do that, because I have raised to the power k over here. Okay, so this is the answer. You can verify it again by choosing some particular values in n and k, and it will work. Say you can verify it by choosing n to be 3 and k to be 2, and find and try to expand on the left hand side, write in terms of the summation, verify the coefficient. Okay, let's move ahead. Now the third is very straightforward, very easy. You have to use this binomial theorem result in order to find the answer. You have to simply find nck. So they reduce to 1 basically. This quantity reduced to 1. So what I have to do, on the left hand side, if I substitute my x to be 1 and y to be 1, if I substitute x to be 1 and y to be 1, then this quantity summation k running from 0 to n choose k. I am using the binomial theorem, try to remember. 1 to the power k, 1 to the power n minus k. On the right hand side it will be using this 1 plus 1 whole to the power n. So the answer is 2 raised to the power n. Okay. Finally, we have to prove this result that n choose k is same as n minus 1 choose k plus n minus 1 choose k minus 1. So this we have to prove. Let's try to prove this one also. Or I can leave it to you. I want you to use the binomial theorem and verify this one. Using the binomial theorem, try to prove this one. If you have some doubts, then do drop it in the comment section, or you can ask in our Telegram group, whose link you can find in the description. So stay tuned. The real analysis course is coming very soon. So do join the Telegram group, that will be helpful. And if you find this video to be useful and interesting, then do give a like. And if you're new to our channel, then definitely do subscribe it and press the bell icon for receiving the notification at the earliest. Thank you so much for watching.